Well, good evening. In conjunction with National Oceans Month, welcome to the Arctic, Climate Change, and How to Get Involved with Robert Pickart, Ben Kopeck, Cara Di Camillo, moderated by Dr. Katherine Straub. Before I turn things over to Dr. Straub, I want to let you know that this session is being recorded. And I want to welcome several members of the Susquehanna University faculty and staff who are joining us tonight, including President Jonathan Green and First Lady Lynn Buck, Melissa Kumura, Vice President for Advancement. Also from the advancement team are Liz Hahn, Chris Markle, Jody Swartz, and Logan Sweet. I'd like to say a special hello to Emeriti faculty, Fred Gross from Physics and Susan Hedgeberg from Music. If you have questions tonight, please use the Q&A and we'll do our best to answer them at the end of the session. Tonight's moderator is Dr. Katherine Straub, Dean of the School of Natural and Social Sciences and Director of Susquehanna's Center for Environmental Education and Research. She earned a bachelor's degree in Earth and Planetary Sciences from Harvard University and a master's degree and a doctorate in Atmospheric Science from Colorado State University before joining Susquehanna in 2002 as a professor of Earth and Environmental Sciences. Her contributions to Susquehanna are many, including developing an interdisciplinary major in environmental studies and a minor in sustainability management, creating and overseeing the Office of Sustainability, and obtaining over $1.6 million in external funding to support the work and research of Susquehanna's Freshwater Research Institute. In her role as dean, Kathy oversees 8 academic departments in natural and social sciences. Kathy, I'll let you take over from here.
All right, thank you, Susan. It is my pleasure tonight to introduce our 3 panelists. So first, Robert or Bob Pickart graduated from Susquehanna in 1981 with majors in physics and math and was a member of the cross-country and track teams. In 1987, he earned a Ph.D. in physical oceanography from MIT. He was introduced to oceanography the summer before his senior year when he spent a month at sea near Brazil as a Woods Hole Oceanographic Institution summer student fellow. He then later joined the Woods Hole staff in the Department of Physical Oceanography and is still there, now a senior scientist at Woods Hole. Over the course of Bob's career, he has sailed on over 50 research cruises and has more than 180 scientific publications in peer-reviewed journals. His research focuses on high latitude processes, including air-sea interaction, deep convection, and shelf basin exchange. Bob does field work in the Arctic Ocean in both the Atlantic and the Pacific sectors using a variety of techniques. And many of his cruises include an outreach component for school children and the lay public. Bob and his wife live on Cape Cod, Massachusetts. And Bob was honored here at Susquehanna in 2016 as the Claritas Distinguished Science Speaker and gave what I thought was a fascinating lecture about physical oceanography. So our second panelist, Ben Kopeck, proud to say a former student of mine, graduated from Susquehanna in 2010, where he was an Earth and Environmental Sciences major, a math minor, and conducted research with Dr. Ahmed Lashab examining water quality in the Susquehanna River. Ben then went on to earn a PhD in Earth Sciences from Dartmouth College, studying the Arctic water cycle, with a particular focus on the role of sea ice in the Arctic climate system. He then served as a visiting professor at St. Olaf College, teaching environmental studies. And during his time there, Ben and I were able to serve together on a panel discussion in 2018 at the American Geophysical Union Fall meeting called The Adventures, Opportunities, and Challenges of Being a Geoscience Faculty Member at a Primarily Undergraduate Institution. Currently, Ben works as a postdoctoral research scientist at the University of Alaska Anchorage, continuing his research work studying the changing Arctic Ocean and atmosphere. And he and his wife live in Minnesota. Welcome to Ben. Our third panelist is Cara Di Camillo. She graduated from Susquehanna in 1999 with a degree in communications with a concentration in public relations and a minor in writing. She currently serves as the New England communications lead for BHB Incorporated, which is a civil engineering firm based outside of Boston that focuses on delivering sustainable, resilient, and equitable solutions for clients and their communities. Within her own Newport, Rhode Island community, Cara is an advocate for healthy oceans, land conservation, and environmental awareness, and possesses a deep knowledge of sustainability. Through her passion, she volunteers with several organizations whose missions are dedicated to safeguarding our natural resources. She's currently a member of Newport's Tree and Open Space Commission, organizes the Newport chapter of Green Drinks, which hosts monthly networking and social gatherings for those interested in the environmental industry, and is a former board member of Clean Ocean Access. Cara is also a recipient of Susquehanna's Alumni Award for Service in 2019, and in 2016 was recognized in Newport Life magazine as a top 10 groundbreaker for her community involvement. So welcome to all three of our panelists. So tonight's discussion will take place in three parts, beginning with Bob, who will talk about one aspect of Arctic climate change and describe the field program that he carried out last year on the US Coast Guard Cutter Healy to learn more about this. So I will turn it over to Bob at this point.
Okay, can you see my screen? All right, we good to go? All right, hello everyone. It's my pleasure to be able to speak with you tonight. As Kathy just said, I'm going to tell you about one aspect of the melting Arctic and also tell you about a field expedition that we had last fall to try to understand more about it. So I would venture to guess that just about everyone on this call tonight is aware of the fact that the warming climate is causing the Arctic pack ice to melt. But you may not really appreciate how quickly that's happening. And here I'm showing you a graphic from NASA that shows you a snapshot of the Arctic ice cover on September 15, 2020. And here's the ice cover there, right? And I should tell you that September is the time of year when the ice cover up there is at a minimum. But I want you to compare that to this yellow line here, which is showing you the average ice edge over the time period 1981 to 2010. And satellite measurements began in 1981, and that's why that's there. But you can see graphically the shrinking of the ice cover. And here I'm showing you a time series from 1981 that shows you the ice concentration. And you can see it's not monotonic, but there's a clear trend of decreasing ice cover. And since the 1990s, the pack ice has decreased in area by 30%. And some models are actually predicting that just in a few decades, the ice cover is going to vanish in the summer, which is just really hard to fathom how quickly this is happening. So that's the Arctic pack ice. Now let's consider Greenland, which is also a source of ice. Greenland is also melting pretty steadily. And here I'm showing you a graph of the mass loss from Greenland in gigatons. That's a big number from 2002 to 2020. And you can see, again, there's a really clear trend of increasing mass loss. And over here on the left, I'm showing you a picture of the accumulated loss since 2002. And the colors are representing the ice mass loss in terms of an equivalent fresh water. So that's if you melted the ice, that's how much fresh water you would have. And you can see that some of these colors are up to 5 meters of fresh water. So that's a lot of fresh water. And the other thing I want you to notice is that most of the melting is happening along the perimeter of Greenland, okay? So more about that in just a second. Now, if Greenland melts completely, the global sea level is going to rise by about 7 meters. And that's more than 20 feet. And that would be, not surprisingly, catastrophic. So the big question is, what's happening to all this extra fresh water due to climate change? One thing to keep in mind is that if that fresh water were to spread over some of these seas that I've mentioned here, or I've labeled here in my graph, that would be enough to potentially slow down or even halt what we call the global overturning circulation that helps maintain our climate. So that would be a huge ramification if that were to happen. But to understand exactly where this fresh water is going, you need to understand about the oceanography of the region. And that's where I come in as a physical oceanographer. So we know that there's a current that navigates around Greenland. It's called the Greenland Coastal Current. Here's a schematic of it. Okay, it goes around the southern tip and into Baffin Bay. And in here, we're a little less certain about what happens to that current. So as you can imagine, most of that fresh water that's leaving the Arctic is entrained into that current and flows in it. And a lot of the ice melt coming off the ice cap also gets entrained to that current. All right, so that's a crucial part of where that fresh water goes. Now, the other aspect of the oceanography of the region that's really important, it goes back to what I just said about the fact that the melting is happening around the perimeter of Greenland. All right, so it may be a surprise that it's not just the warming air temperatures that's melting the Greenland ice cap. It's largely due to the warm ocean water that's coming up against the glaciers and melting the underside of the glaciers. That's a huge part of this, okay? And the reason for that is the Gulf Stream system. And I'm sure most of you have heard about the Gulf Stream or know about the Gulf Stream. So as you go north, the Gulf Stream changes its name to the North Atlantic Current, and it breaks up into a bunch of different branches that you see here. And one of those branches carries the warm water around, and it flows adjacent to and underneath this coastal current. And somehow that warm water in that current is making it onto the shelf and next to these glaciers and causing this basal melt. So two big questions then are, where does the fresh water go? And how does this warm subtropical origin water access Greenland's glaciers? So those are two of the big questions that we had in mind when we set out on this expedition last fall on the Healy. So our plan was to sample the region of Baffin Bay. And that's partly because, as I just told you earlier, we're pretty unclear about what happens to that coastal current up in this area of Baffin Bay. So in this diagram here, I pointed out the 5 biggest glaciers in West Greenland, okay? In particular, this one, Jakobshavn, which is the biggest outlet glacier in all of Greenland. And the hypothesis is that this warm water that I just told you about, as it flows to the north, somehow gets steered into these deep troughs in the continental shelf. And it brings that water up close to the coast and contact with these glaciers. So that's the hypothesis. And this is sort of a schematic of what that might look like. So that's hypothesis number 1. Hypothesis number 2 is the meltwater that's coming not only from the glaciers, but from all around Greenland is getting entrained into this current and then somehow escapes that current and gets into Baffin Bay and perhaps into the Labrador Sea. So those are the 2 hypotheses. So the program took place on the US Coast Guard Cutter Healy. Here's a picture of the Healy. It's the largest ship in the Coast Guard fleet. It's also the only heavy icebreaker that's available to the science community. And we caught the ship in Nuuk, Greenland. I should say that the Healy is based in Seattle. And the way it got to Greenland is it went above Alaska through the Northwest Passage, exited Lancaster Sound, and came down and picked us up here. So we got on the ship and we did a lot of crisscrossing here through the bay, but you can see we concentrated a lot of the measurements in these areas near those glaciers. So what measurements did we take? There were 8 different science programs on the cruise, and you're going to hear about another one of them in just a minute when Ben talks. But all of these programs were centered around what we call a hydrographic survey. And by hydrographic survey, I mean we tried to assess the characteristics of the water and the movement of the water, all right? And we did that primarily with an instrument that you see a picture of here called a conductivity temperature depth instrument, or CTD for short. And the CTD is mounted on what we call a rosette. So you're looking at the rosette here. The instrument is down below, right there. And around the rosette are these plastic bottles that we use to capture water. Okay, so I'm going to describe what a typical CTD cast is like as I show you a movie here of the Healy recovering the CTD during one of our casts. So essentially what we did as we crisscrossed the basin is we stopped the ship many times, actually more than 200 times, and we lowered that instrument down to the bottom. And on the way down, it gives you a trace of temperature, salinity, oxygen, other things like turbidity, fluorescence, things like that. And then on the way up, we stopped the package at various depths in the water column, and we would capture water in those plastic bottles. And that way we can measure other quantities that can't be measured electronically, such as nutrients, isotopes, CFCs, things like that. So after every cast, we'd land the package on the starboard side deck there, push it into the hangar, and then the scientists would go around and take their samples and either measure them on the ship or send them home to be measured after the cruise. And we would download our electronic data. So we had our challenges on the cruise. Now we were on this really big, powerful Coast Guard icebreaker, but this time of year, there was no pack ice in Baffin Bay. So that wasn't a problem. The problem was the icebergs, all right? There are tons of icebergs that are being calved from these glaciers. So, and we were trying to get close to the glaciers. So here's the Jakobshavn trough that I told you about, and we did these 2 sections there, and we wanted to get as close as possible. But the problem was the iceberg density was just too high to make that happen. So here, this is an ice analysis from the North American Ice Service for September 30th during our cruise. And this is where we wanted to go. And according to this analysis, there were 1,700 icebergs in our way. So there was no way that the Healy was going to go into a region with 1,700 icebergs. So to get around that, we deployed an autonomous vehicle that I'm showing you here being deployed. This is called a glider, okay? And it's got a propeller on it. And there it is getting launched. And it dives and rises and makes a sawtooth pattern through the water, all right? And it can go in regions where the ship can't because it's so small and maneuverable. And this is actually where it went. We launched it here, and it crisscrossed its way across the Jakobshavn Trough and went even up to close to these two islands. So again, into a region where the ship couldn't go. So that's a really valuable data. Okay, so 8 different programs, lots of different results, and I could show you a bunch of different things, but I have a very short amount of time, and I just thought I would focus on one small snippet of results. And the thing that I've chosen to show you, I did it on purpose because it's both exciting and also challenging, and that sort of sums up what happens to us when we go out on these cruises. So here we are trying to get close to the Umanak Trough here, and we did these 2 sections, all right? So let me show you what the first outer section looked like. And this is showing you a picture of the depth average velocity. Okay, these are vectors. So here, this is the trough, and here's the flow going in on the southern part of the trough, all right? And here's the flow going out on the northern side of the trough, all right? Now, if you take a slice through the water column, all right, this is what that looks like. So this is a slice showing you the temperature. You're looking onshore here. So here's that warm surface water that's going to melt the glaciers. And here it is flowing in and flowing out. So this was kind of gratifying to see. This is exactly what we hypothesized and what we expected, okay? So we're looking good at that point. But then 24 hours later, we occupied the inner section and we saw the exact opposite, all right? The flow is going in on the north and out on the south, all right? Totally unexpected, kind of turned things on its side there. And so it's not untypical for us to come up with surprises like this. And so I'll tell you that we're going to spend the next year or so trying to parse through all our data and understand things like this surprise. Clearly, there's some sort of time-dependent process happening there that we're going to have to figure out. And then we're going to have to figure out what difference that makes in terms of melting the glaciers. Okay, so I'd like to close with telling you something about the category of It's a Small World. All right, so we were in Nuuk and we were ready to board the ship. And I was chit-chatting with a young scientist who I had just met. And, you know, we're asking the normal kind of things. Where are you from? What do you do? What kind of measurements are you going to take on the ship? And then I asked him, so where'd you get your PhD? And he said, Dartmouth. I said, oh, that's interesting. My son went to Dartmouth. And then we talked a bit more and we figured out that they overlap with each other. So I thought that was, wow, that's really interesting. And then I said, oh, and so where'd you get your undergraduate degree? And he said something like, well, it's a small liberal arts college in central Pennsylvania. I'm thinking to myself, no way, no way. And then boom, Susquehanna University. So I was like, wow, that is really amazing. So it was a really great connection to make. I also want to tell you that we chatted some more, and even though we graduated almost 30 years apart, we had the same professor while we were there, which is just amazing. And that professor was Fred Gross. And I think Fred is listening in on this call. So hi, Fred, and thanks for everything you did. Thanks for, turning me into a physical oceanographer. So appreciative. So anyway, Ben and I have been talking about how we're going to combine our science to try to do some collaborative analysis. And the last thing I'll say is that we've also have some plans now to sail again with each other this fall in the Pacific sector of the Arctic Ocean. So I'll stop there and thank you very much.
Can you all see my screen? Good. Awesome. Hi, everyone. I'm Ben Kopeck. Thanks a lot, Susan and Kathy, for putting this all together, and thanks to all for being here. So, and thanks, Bob, for this great introduction on the Arctic system. So, as you talked about, we shared this amazing experience on the cruise this fall. So, in this short presentation, I'll share some of the work we did. Certainly overlap on this topic of the freshwater input. So I'm going to talk about a bit of a different section of these Arctic changes, and in this case, it's thinking about the role of sea ice in the water cycle and its larger impacts. But just real quickly before getting started here, Kathy kind of went through my quick introduction here, but through my pathway to this cruise, starting at Susquehanna, did a lot of exciting research with Dr. Straub, looking at different water quality issues in the area, and then went off to Greenland, where I was fortunate to get to do some field work in Greenland, among other places, to learn about the changing Arctic systems. Met my partner, Alden, in grad school, and then we moved to Minnesota together, where we each taught at St. Olaf College. She's in the physics department there as a tenure track faculty member, and also does a lot of climate work. So Minnesota's home now, but I've been working for the last couple years at the University of Alaska Anchorage remotely. Similar work looking at the changing Arctic water cycle. And I've got my dedicated partners, my wonderful 2 cats, who are always here to help out with our work. So yeah, with this research, I've been really fortunate to get to travel to some amazing places with several field seasons in Greenland. All of my time has been spent on land or on ice. So this cruise was a very new experience for me. Bob, I think, mentioned 50 cruises, I believe, something like that. This was my first opportunity on the water. And so, yeah, so my experience started here in Nuuk, Greenland. As Bob said, we sailed on this small boat to approach the massive Healy icebreaker ship. And what I noticed as we're approaching is that we have to board the ship via this wild 40-foot super steep staircase coming right up the side of the ship. I was very much thinking, what have I gotten myself into here? As I did imagine, the experience was going to be great. It was. We had a wonderful group of people and saw some amazing sites, great research, and some highlights for sure were watching a few sunrises over the Greenland ice sheet from over the ocean. That was a very special experience. So this cruise, over the full scope of the cruise, starting in Alaska. What was really neat about the whole mission overall for the Coast Guard was traversing the Northwest Passage. And so obviously this is a very historical route that's been a great challenge to navigate due to the presence of ice across a lot of this area. But this is becoming much more feasible to do with the loss of sea ice. And so at many times of the year, certainly in the past, we had a much larger ice extent kind of positioned all across the Arctic. This traverse would have certainly been impossible or significantly more challenging in past years or other times of the year. But when this cruise happened, we were able to pass through this entire region. And as I've said, we didn't have any sea ice in the Baffin Bay portion of our cruise. Only just got to see some truly amazing icebergs around us, but sea ice was not present. And so, as we talked about, sea ice has been declining steadily over the last few decades. And as you're seeing the cruise track again on here, the cruise only encountered some ice kind of in the Canadian islands, but even that wasn't kind of strong, 100% old sea ice. It was so they were able to make this cruise successfully through the Northwest Passage. And so this loss of sea ice has had a wide range of impacts across the climate system in the Arctic and across the globe. The ice is a fundamental component of the system. The one that I want to focus on here is its role within the water cycle. So as we've seen significant warming in the Arctic, and the ice has melted a lot over the last several decades. And so we now have the sea ice that has been capping the ocean. Now the ocean is able to communicate with the atmosphere. So in this case, as we start to open up the Arctic seas, we see increases in evaporation that's possible now, where the water vapor content in the atmosphere has increased a lot. And subsequently, we see an increase in precipitation across the Arctic. And so one of the real key things that we're focused on is kind of trying to quantify this link. How much is the water vapor and how much is the precipitation increasing? And alternatively, where are these increases most prevalent? So in order to work on trying to quantify this, my team at the University of Alaska Anchorage has been working together here with an international group to build up what we're calling the Arctic Water Isotope Network, where our primary tool are to measure the isotopes of water. So a water molecule, 2 hydrogen atoms, 1 oxygen atom. These atoms can have different isotopes. Say with oxygen, we'll be looking at oxygen mass 16 or mass 18. And we can measure the ratio of those different isotopes in any mass of water, whether that's in water vapor, in rain, or in seawater, in ice. And these isotopes are, these ratios store kind of the history of that water, and it provides a tracer of these hydrologic cycle processes. And so with this network here, we've focused on setting up different water vapor analyzers around the Arctic in order to measure this content in the atmosphere. And by having a network, what's really great is we can trace moisture as it moves from one site to another, and ultimately try to get at how much water is added along the way. And so this water vapor that's evaporating from these cold Arctic sources has a really unique isotopic signal. And so we can pick that up when we're seeing moisture that's been added between 2 sites. And so these kind of changes in the air mass allow us to quantify just how much water has been added along the way. So this evaporative signal that I was mentioning, we can pick it out, but there's still there's variations in that signal. So it's really important for us to fully understand what those ranges signals are and under what conditions, what the isotopic numbers look like in order for us to best quantify these additions along the track. And so that's where the measurements on this cruise came in. Measurements over the ocean surface are quite limited, and they're limited in the Arctic overall too, but to have these measurements directly over the ocean surface are really important for us to better understand this new source of evaporation. And so on the Healy, in addition, we measured the seawater and we took samples for the CTD, but here we're looking at a water vapor isotope analyzer. And so this is set up in a room that's in the bow of the ship. It's connected to tubing that goes up onto the deck of the ship and is then positioned over the front of the boat, over the ocean surface, directly sampling air as water evaporates and mixes into the atmosphere. And so we measured these water vapor isotopes over the entire length of the cruise from Alaska all the way back around through the Northwest Passage, Baffin Bay, and back to ultimately to Boston. And so we could get this observation over a huge spatial range, over a wide range of climate conditions, and this will really help us constrain this important evaporative flux. So this link between the precipitation and sea ice is really important on a number of different levels. Our group in particular is really interested in its impacts on the Greenland ice sheet. This increase in precipitation, the impact of it really depends on what form of precipitation it falls as, whether it's rain or snow. Those will have very different impacts on the mass balance. All of this new precipitation is creating a larger freshwater influx into the oceans, further altering the circulation that Bob was mentioning, among many other changes. These effects of sea ice are far-reaching beyond just the Arctic. One of the big projects that our group was working on prior to me getting there was looking at this impact of the ice loss on a huge European snowfall event. And what we were able to find with some of our water vapor measurements was this large influx of moisture that had evaporated from areas that would have previously been covered by sea ice. These changes kind of expand across the Northern Hemisphere in different ways. Another one that we're particularly interested in is thinking about how the warming Arctic and in response in part to the loss of sea ice is altering circulation or the changing of the jet stream. This is still very much an active research question to understand the full effects here, but one of the things that we see is a dramatic shift in how much transfer of air there is both northward and southward. So you're getting a kind of a wider range of temperature and precipitation variations associated with these changes in the jet stream. This has been super pronounced in a variety of weather events lately in the country. In Minnesota, we had a particularly challenging summer last year, where we were kind of in this alternating phase of this air coming in from the north that was bringing in all of this wildfire smoke from kind of across Canada, and then it would flip to super hot, humid air masses coming in from the north. Sometimes that would even bring in additional wildfire smoke from US west. These atmospheric circulation changes are causing shifts to hurricane tracks. Sandy in 2012 was linked to the shift in that was linked to sea ice, in addition to kind of steering some of the more recent hurricanes as well. And these circulation changes are certainly linked to changes in these extreme droughts that we've been seeing out west and helping fuel these wildfires. So these changes in the Arctic are certainly far-reaching beyond. So I'll finish up here with just a quick note. As Bob said, we're going to be sailing again together this fall. Super excited to be able to explore both another area of the Arctic, this time kind of around Alaska and the surrounding regions. Be taking a lot of the similar measurements, exploring these topics, but at a different time of year and different ice conditions. So it's a great opportunity for research, and I'm glad that Bob and I will be joining each other again. So I will wrap up here. I'd be more than happy to take any questions from anyone after this or after the event. And thank you all for listening.
Okay, hi everyone. Hopefully you can see my screen. Yes, okay, good. Okay, hi everyone, and thank you so much to Bob and Ben. Very interesting stuff there. So this is where I come in. What can you do? There's actually a lot that each of us can do to help slow the rate of climate change. Greenhouse gases trap heat and make the planet warmer. Human activities are responsible for almost all of the increase in greenhouse gases in the atmosphere over the past 150 years. Americans on average produce 21 tons of carbon a year, which is just one type of greenhouse gas. And that's about 4 times the global average. The largest source of greenhouse gas emissions from human activities in the US is from burning fossil fuels for electricity, heat, and transportation. Decisions that we all make today can shape the world for decades and even centuries to come. Not only are these actions good for the environment, but they're also good for personal and community health, equity, environmental justice, quality of life, and our shared futures. I'm going to give you a lot of information here, and some of it you may have heard many times, but one thing to think about is that it might not be utilized within your neighborhoods. Some isn't accessible for everyone, so do what you can do. I'm going to share some highlights and things that I like to think about. So first, let's talk about energy, since it's one of the biggest culprits. And there's a lot to talk about here. Saving energy and using cleaner energy sources is one of the most cost-effective ways to reduce greenhouse gases. So look for the Energy Star certification label on energy efficient products, including appliances, lighting, heating and cooling equipment, electronics, and office equipment. In addition to saving you money on energy bills, many utilities offer rebates on Energy Star certified products. You can also claim federal tax credits for many energy efficiency home improvements. To help you figure out where to start, some utility companies offer a home energy audit free of charge. Personally speaking, I had one completed in the fall last year by my utility company, and I received a report on what steps I can do to improve. So for the average American household, almost half the annual energy bill goes into heating and cooling, and that is more than $900 a year. So heat and cool your home smartly by properly sealing and insulating your home. If possible, install a smart thermostat to automatically adjust your home's temperature settings for optimal performance. It can reduce your heating and cooling bill by more than 8% and save you about $50 a year on average. If your home is unoccupied much of the day, a smart thermostat can actually save you about $100 a year. So since summer is here for many of us, air conditioners are top of mind. Energy Star certified models use 9% less energy than standard models and on average cost less than $70 per year to run. Be sure that the window unit fits tightly in the window so outdoor air isn't getting in. And to keep out the heat of the summer sun, close window shades and drapes in the warm weather. During the cold weather, take advantage of the sun's warmth by keeping drapes open during the daylight hours. Lighting is one of the easiest places to start saving energy, and I'm hoping that many of you have already replaced your 5 most frequently used light fixtures or bulbs with your Energy Star certified lights. It can save you nearly $45 a year in energy costs. LED light bulbs provide high quality light output, use up to 90% less energy, and last 15 times longer than standard bulbs. Consumer electronics also play a large role in your home's energy consumption. The outlets in your home are likely powering about 65 devices, which is an average load for a home in the United States. A home that's equipped with TVs, Blu-ray players, cable boxes, sound bars, even if they've earned the Energy Star rating, that can save you nearly $140 over the life of those products. Use a power strip as a central turnoff point. Did you know that even when turned off, electronic and IT equipment can still use a small amount of electricity? Using a power strip for your computer and all peripheral equipment that goes along with it allows you to completely disconnect the power supply from the source, eliminating standby power consumption. Cordless vacuums and power tools and other electronics use energy even when they're not charging. This idle load across all US households add up to the output of 50 large power plants in the country. So don't leave fully charged devices plugged into your home's outlets. Unplug rarely used devices or plug them into power strips and timers. This also goes for cell phone chargers as well, which I know that we're all guilty of. And while it might not be feasible for everybody, installing solar panels can be one of the most effective ways of saving energy and saving greenhouse gas emissions. They're made to last more than 25 years, only require maintenance and cleaning once a year, and the average home can save between $10,000 and $30,000 over the lifetime of the solar panel system. Not to mention, there's currently a 26% tax credit right now for installing them. If solar isn't an option, which it isn't for many of us, look for a certified green energy company. These companies generate at least half their power from wind or solar. If that isn't possible for you, take a look at your electric bill. Many utilities now list other ways to support renewable sources on their monthly statements and on their websites. And finally, if you rent, and these are things you can't change on your own, share these tips and encourage your landlord to help you make a change for the better. So next, we're going to talk about waste. In the United States, the average person generates 4.5 pounds of trash every day. So the most effective way to reduce waste is to not create it at all. Save money, conserve natural resources, and reduce greenhouse gas emissions by practicing the 3 R's, which we've all heard many, many times: reduce, reuse, and recycle. You can help reduce greenhouse gas emissions by thinking about the environmental impact of the product you're purchasing. For example, consider a product's durability, sustainability, and how easy it can be recycled after you're finished with it. Approximately 10% of US energy use goes into growing, processing, packaging, and shipping food. about 40% of which winds up in the landfill. Food is the single largest category of material dumped in municipal landfills, where it emits methane, another powerful greenhouse gas. Reduce your food waste by shopping smart, buying only what you need, eating what you have, composting your food scraps, and donating unused food to food banks or shelters. You can reuse or repurpose items such as old clothing, cloth grocery bags, and containers to cut down on the amount of waste you create. Buying used items reduces waste and the emissions created by producing new materials or disposing of them in landfills. Donate your old items to make sure others can reuse them as well. Locally, I donate to Big Brothers Big Sisters, who will happily accept cloth of any kind and many home items as well. Buy products that are made with recycled content and check the labels to see if the packaging is made from recycled content as well. Lastly, know what items your local recycling program collects and encourage your friends, neighbors, and your company to recycle right and recycle more. There are many items that my own local municipality doesn't collect. However, those items such as styrofoam, hard plastics, metal items, and appliances are accepted at my state landfill. So I make a trip usually twice a year to ensure those items are recycled correctly. You can make a difference by reducing the environmental impact of fuel emissions. If you currently use green transportation, continue doing so. Biking, walking, carpooling, and public transportation can significantly reduce greenhouse gas emissions. Do you know if your employer offers commuter benefits for public transportation or carpooling? Many do so make sure you check it out. Improve your fuel economy by driving smart. If all Americans kept their tires properly inflated, we could save 1.2 billion gallons of gas each year. A simple tune-up can boost miles per gallon anywhere from 4% to 40%, and a new air filter can get you a 10% boost. Also, remove unnecessary accessories from your car roof. Roof racks and clamshell storage containers can reduce fuel efficiency by as much as 5%. If you're looking for a new car right now, choose an energy efficient one by looking for models with higher miles per gallon, or switch to an electric vehicle if you can. Come 2025, all cars and light trucks must meet clean car standards, which means averaging 54.5 miles per gallon, so they'll thankfully be a mainstay. And finally, make fewer trips. Activities such as grouping errands to make fewer trips and telecommuting, if you can reduce both fuel and greenhouse gas emissions. As the climate changes, some communities could face water supply shortages and impacts to water infrastructure. It takes a lot of energy to pump, treat, and heat water. So conserving water reduces greenhouse gas emissions too. Using water efficiently at home is a no to low cost. Turn off running faucets when you're brushing your teeth and run your washing machine with a full load using cold water. If you're going to be shopping for a new washing machine or dishwasher, again, look for the Energy Star label. Running your low energy dishwasher actually saves more water than washing dishes by hand. Check for water leaks in your home and workplace. Did you know that a leaky toilet can waste 200 gallons of water per day? Luckily, leaks from toilets, faucets, and pipes are often easy to detect and fix. Consider installing low-flow shower heads and take shorter showers. Cutting your shower time by even a minute can help save gallons of water. And finally, have a water smart landscape by using native plants and trees, and design a landscape suitable to your client. Make sure to learn when and how much to water. To circle the conversation back to the Arctic, there are currently about 4 million people who live there, many within a built environment, of course, like cities and communities. But there are approximately 400,000 indigenous people living in the Arctic as well. This is their homeland. These indigenous communities rely on ice to live, whether it's hunting or fishing or dwelling. Climate change and global warming is melting this infrastructure. What they've relied upon is buckling due to coastal erosion and flooding, as we learned. Their communities are disappearing. This is an example of environmental justice, and it might be a term you've been hearing a lot about these days. From extreme heat to rising sea level, climate change can have unequal effects on underserved and overburdened populations. It's good to note that these inequities were not created overnight and are deeply rooted in our laws, policies, and institutions. But addressing these disparities is key to advancing effective climate change solutions and will require thoughtful partnerships and meaningful involvement of the individuals and families who are closest to the problems. So get to know your own community by learning what climate issues threaten your neighborhoods, who is most vulnerable, and how you can help. Plant trees wherever you can, but don't stop there. Tree plantings, community gardens, green roofs, and other actions can all help cool urban heat islands. Under-resourced communities are especially vulnerable to the impacts, particularly in the summer months. Learn in which communities that large industrial U.S. greenhouse gas emitting facilities, such as fossil fuel fired power plants, are located and how much they emit. Discover ways you can work with your neighbors and your community to integrate smart growth and environmental justice to prepare for and lessen the impacts of climate change, address disparities, and build healthy and sustainable neighborhoods. And finally, get involved. Local governments have voluntary advisory boards and neighborhood councils where you can help to shape policies and funding decisions. They need diverse participants, including people from the neighborhoods most affected by climate change and health and environmental hazards. Encourage your neighbors to get involved as well. If you want to learn more, the EPA website is a really great resource for environmental justice. And still, there's more. Consider ways to deepen your knowledge and spread the word to make an even bigger impact. Educate children and young adults about how we all contribute to climate change and can make a difference by changing our own behaviors. Promote environmental stewardship by encouraging your school or workplace to reduce their greenhouse gas emissions by managing their energy use and waste generation. Estimate your annual greenhouse gas emissions by using a household carbon footprint calculator. Help increase climate change data and understanding by participating in citizen science projects, which encourage public participation in scientific research. And finally, share your knowledge and speak up. Tell others in your home, school, workplace, and community how they can reduce greenhouse gas emissions and take other climate protection steps, and make sure your representatives are making good decisions. So I hope that we've shown you how interconnected everything is. And in closing, I just want to reiterate that there's so much that you can do. It can be overwhelming, but I'm going to leave you with this question. What is it that you care about? Pick a topic, learn more about it, and take action. Thank you.
All right, well, thank you so much to our three panelists. We have about 10 minutes that we can hopefully have you guys answer some questions. So one question that I'd like to start off with that was submitted online before tonight's webinar is, I think I'm going to ask Bob to answer this one. How much time do we have before the permafrost starts releasing heavy amounts of methane? Is it too late?
All right, thanks, Kathy. So that's really not my area of expertise. But I do know about the melting permafrost. I mean, one thing that I did a sabbatical up in Alaska and saw it firsthand with my own eyes. And I also know that one of the things, and Cara talked about this, is these storms that can cause huge erosion that's getting in and impacting the permafrost as well. So as far as the methane question, I know it is an extreme greenhouse gas, but I really don't know the numbers there. But as far as things happening quickly, they are happening quickly. You know, one of the things that people talk about with climate change is that, you know, people don't really pay attention to it because they don't really see it happening in real time, if you will. But, you know, I've been going to the Arctic for two decades now, and in those 2 decades, I see huge changes. You know, not just the shrinking ice, you know, but, you know, we're seeing more storms, we're seeing more phytoplankton grow all over the place. We're seeing harmful algal blooms or red tides for the first time ever up in the Arctic that are impacting these communities that Cara talked about. But one tidbit I will give you about the permafrost is that it shocked me to learn that the amount of carbon stored in the frozen permafrost up there in the Arctic is more than twice the amount of carbon that's presently in the atmosphere. So that just gives you just an inkling of how big of an impact this is going to have if it starts to melt. Thanks.
All right. So our next question is for Ben. So Ben, can you explain the connection between melting Arctic ice and smoke in Minnesota?
Yeah, absolutely. It's I mean, there's any of these things are complicated connections that are happening. That's what so many of the climate various impacts are, is just one thing leads to another thing. There are these feedbacks that are connected across all sorts of different spatial scales. So with this particular one, what we're seeing is the warming of Arctic and the loss of sea ice is creating this positive feedback that's even warming the Arctic even more. This warm Arctic is then driving these, it's driving the way that the atmosphere flows around, the way that it moves. And so these, one of the potential impacts here is that the jet stream is going to start, it could become wavier or get stuck in these big waves in the jet stream. A lot of the things out, say the drought out west and in the US or up in Canada, a lot of this, if we get stuck in one of these big troughs in the jet stream, it's just going to be long, prolonged dry periods. This is adding fuel to the wild fires that are occurring. And so in that sense, this is how sea ice is connected to causing an increase in the wildfires by increasing the prevalence of helping. So the sea ice changes the atmospheric circulation, which changes or adds to helps exacerbate the droughts and the wildfires. And then the same atmospheric changes will then direct the smoke that's caused by the wildfires in, say, in Manitoba. And in the case of Minnesota, is kind of this pathway right from the north that drops right down into where we are in Minnesota. And so we saw this repeatedly all through the summer, this kind of off and on cycle where there was a bunch of wildfires in this dry zone up north of us. And as the winds would shift from the north, we would see this smoke just pile into Minnesota. It's not very unpleasant. I mean, for me, it's just, it impacts my outdoors activities and whatnot, but the air quality impacts are vast. It impacts communities all across the state. And I mean, air quality in general is a huge environmental concern to everyone, especially susceptible communities. And so it's really important to think about this impact, whether that's in Minnesota or anywhere.
Great, thank you. Yeah, so sometimes it's hard to make the connection between things that are going on a long time scale, like climate change and the melting Arctic sea ice, and a specific weather event, right? Like smoke in Minnesota on a particular day. But you have to, it's statistics, right, that gets you from one thing to the other. And it can be more likely, you can be more likely to experience effects like that, right, because of climate change.
Certainly, yeah. I mean, it's like, can I say that the sea ice caused this wildfire smoke in my backyard? Even last week we had some smoke in Minnesota. So no, but it's all about it's all, as you said, it's all about the likelihood. We're seeing that these events and the conditions are happening more frequently, or more the intensity of these are happening, or the intensity is increasing, intense events are happening more frequently. And so it's all, it's connected. We're seeing it all happen kind of more frequently. And so, it's a growing concern as the warming trends continue and the loss of ice continues and whatnot. Yeah.
I'll just add real quickly, Kathy, that you hit the nail on the head with statistics, but that's also something that's really hard for the public to appreciate, right? To take that longer term view. And also you throw on top of that natural variations, which happen in any climate, right? So it's hard to sort of sort out these trends, and that's what makes it challenging, but it's also, that's why it's really dangerous.
All right, thank you. So Cara, I have the next question for you, which is from a high school earth science teacher who would like to know how they can involve their 9th to 12th grade students in taking action on climate change with a limited budget and B, varying interest levels of the students.
I would say one of the best things to do is to get involved with the nonprofit groups in your community. There are many now in cities and towns that offer very different aspects, whether it be, I'm not sure where you're located, but whether it be a nonprofit that focuses on cleaning the beaches, or there might be a nonprofit that plants trees. There are many, or maybe even goes and picks up trash in the community. There's a lot of different nonprofits out there to get involved with. So that would be my recommendation.
All right, thank you. There's another question that's related, and anybody who wants to jump into this one. Someone is really interested just sort of in general in how to get involved in climate change issues in terms of like resolutions. It sounds like more along the policy lines. Does anybody have any recommendations for that? If not, I do. So there is a group that's called Citizens Climate Lobby that is a bipartisan group that is working with Congress members to address climate change in the United States. It's a really good group because their intent is to have a bipartisan approach to congressional action on climate change. So I would recommend Citizens, and there are chapters all over the country. There's even one here in Little Central Pennsylvania. So I would check out Citizens Climate Lobby. Let's see, let me check we've got a few questions. All right, Cara, does the engineering firm you work with incorporate climate or environmental changes in their design of projects? And if so, do you know if this is required by policy or by professional choice?
Yes, we do. And I would say it's a little bit of both. There are a lot of states now that are requiring certain ways to build. Many of them are striving for net zero. So these are things that our clients are not only asking for, but these are things that we are also recommending, along with building smart communities, and using what we can as far as asset repositioning, which means reusing buildings to build a different business. So yes, I guess the answer to that is yes and yes.
And I have another question go ahead, Ben.
Could I just, I would say kind of related maybe to the past question too, with these changes in some of like building codes or whatever related to that. I mean, there's a lot of towns some have already developed some sort of a climate action plan, but there are many communities that are either in the work that's something that's being planned or will be happening, or you could push to make happen moving forward. I participated in Northfield's climate action plan advisory board and worked on kind of coming up with this plan that we published, I guess it was 3 years ago here in Northfield. So it's something that you could surely be involved in your local communities at any sorts of scale, even a smaller town like here in Northfield. So something I would highly recommend.
Absolutely. Yeah. For a while here in Pennsylvania, the DEP was allowing college students to help communities work on community greenhouse gas inventories and community action plans. So you don't necessarily have to do it yourself. There are methodologies for how you do it right there. They can be pretty complicated, but they can walk you through it. All right, let's do one more question for Cara, and this was just submitted, and then we'll finish up after that. So Cara, how can we include the disabled community's needs and also the growing homeless population in creating sustainable changes? Sometimes new initiatives directly negatively impact populations that need more support, have life-threatening allergies, I think in terms of Ben's comments about the air quality, or become further debilitated when their needs are not included in the new changes? So that was a question for Cara.
And that is a really, really good question. And I can't say that I can speak directly to that, but what I can say is I mentioned in my previous answer, building smart communities. And that I think in thinking about the future and building for the future, we need to think about building these smart communities that allow access to public transportation, that allow access for biking and walking and all of these modes of transportation that are not dangerous. As far as the allergies go, I honestly, I cannot speak directly to that, but it is a question that I'm writing down because I want to know the answer myself, actually.
That's a great question. And I would say on a positive note, there are a number of grant applications that I have seen over the last few years that have an environmental justice component to it, which is, I think, what we're getting at. And so in a lot of cases, if you want to apply for a grant, say through the state or the federal government, you have a higher likelihood of actually accessing those funds if you are thinking about these kinds of populations in terms of environmental justice. So that's a way that, large scale public policy, I think, is pushing some of these changes to the front, which is fantastic. Okay, well, we are about out of time here. So thank you for joining us tonight. This concludes the alumni speaker series for this academic year, but the regional alumni chapter events are just getting started with events this summer, and I have 3 to tell you about. The first is Thursday, July 21st, a happy hour at L'Oreal Plaza in Washington, D.C., and drinks at the Honorable William Wall in New York Harbor. The second is Saturday, August 6th, the Somerset Patriots baseball game in Somerset, New Jersey. The third is Saturday, August 20th, the Nisley Vineyards reception and concert. So for more information about these and other events, go to www.sualum.com. So thank you so much for joining us, and I hope you all have a wonderful evening. Good night.